So, for the topic on motors, once again, the report guidelines, this is in your Google Classroom. The report guidelines are as follows, the rubric is as follows, and the outline, recommended outline for the long report on motors is as follows. So our objective is for you to be able to control the motor movement and construct an electronic sunflower with a light-dependent resistor and motor that rotates to where the light source is brightest. Now you can imagine an application of this is to control a solar panel where the sunlight appears to be brightest. Right? The panel, meaning the orientation of the solar panel. The expected report outline should follow uh, the following uh, topics, no, or or chapters and subchapters. You first research about the type of motors, and I suggest just 3. Then you will talk more about the stepper motor and how it is controlled. Then you will discuss feedback control loops, and I will give a lecture on that as well. Then you will discuss your design for your electronic sunflower, and of course how you constructed it, then results in analysis, and of course self-grade and reflection. For this topic on motors, we have the following very good online resources. Please go ahead and check them. This one is a YouTube video, and this one is a web page with example code that you can follow through. So both of them are very good. By just studying these two, you can already start working on your stepper motor. So the thing is, first thing is you would need to understand how the stepper motor works. So I'm going to stop sharing here, and I'll go to the other screen, my iPad. I'll show you how it works. So if you recall, if you have a wire, you coil it in a loop like so, and you pass current through this wire, what happens? So for example, I put 5 volts across the ends of this wire. So current will pass through, and what will happen? Remember, if there is current, there is a magnetic field. More so, if you coil the spring or coil the wire, then the magnetic field will be strong. All right. So let's have 4 of these. So every time you pass, say, put 5 volts across this wire, you generate an electromagnet, okay, because of the current flowing through. Now, in a motor, there are 4 of these typically arranged as follows. One for north, south, east, and west. So there's one here. Just gonna draw a loop here. Okay, and then another here. And another on the opposite side. So you know also control. Okay, okay. Now let's label this one. Or sorry, it's for reasons that will become clear later. Let's label this as coil 1, 2, 3, 4. Alright, and independently we can put 5 volts across these coils and turn on their magnets essentially. Now imagine that there's a permanent magnet somewhere there, okay, like north south, right? Okay, now what can happen is if we turn on 4, the magnet of 4, electromagnet of 4, like we put 5 volts across uh, the coil here to create an electromagnet, what will happen to this magnet? Of course, it will be attracted. So suppose south ang nakuha natin dito, this generates uh, magnet which is parang south, no? So essentially, ang mangyayari is the permanent magnet in the middle will orient towards number 4. So let's make a table. 4, 3, 2, 1. And then, let's make this table here. So, in the first position, we can turn on, let's say, for turning it on, let's say it's 1, 0, 0, 0. No, let's turn off all the rest of the coils. And then, what will happen is that the permanent magnet in the middle will orient to 4. Now, we can actually turn on two magnets, say for example 4 and 3, such that, and 1 and 2 are off, so that ang mangyayari if 4 and 3 are on, ang mangyayari is our permanent magnet here will rotate pa ganyan 45 degrees kasi kumbaga attract siya ng 4, coil 4 and coil 3. So if we turn on coil 4 and 3, we are at this second position. So the first position is here, the second position is here. Okay, so this is position, let's call this position 1. And this is position 2. And then, naka-off pa rin yung dalawa. No? So you can imagine that is how to control the shaft. Just turn on and off the magnets in sequence. So if we now want this coil to further move this way, rotate this way, anong gagawin natin? We turn off everything except coil 3. We turn on the magnet of coil 3, okay, and turn off everything else. And now it's in the third position. Can you see the pattern? So in the fourth position, we want it to point this way. So ano ibig sabihin nun? We must turn off everything except 3 and 2. No? So coil 3 and 2 should turn on and the rest are off. And so forth and so on. So in the fifth position, naka-point na siya dito, right? So you can just go on and complete this pattern. So pag ganito, in this fifth position, what should you turn on? Everything should be off except coil 2. Coil 2 should be on so that the magnet will point towards it. Okay, I think there will be 3 more positions. Okay, how about this one here? So then, pag ito, gusto nating tumutok dito, so we turn on coil 1 and 2 and turn off this, so that's position 6. And so you can imagine that for position 7, you turn this on, everything is off, and lastly for position 8, which points this way, you turn on 1 and 4 and turn off the rest. Okay? So essentially, that's how basic stepper motor works. So if you look inside a stepper motor, there would be an assembly where there are these 4 electromagnets which can be turned on and off by applying a voltage. The shaft is connected to a permanent magnet, okay, which is controlled, whose orientation is controlled by the coils around it, by the magnetization of the coils around it. Now you can imagine, teka, 8 positions lang to eh. So 360 degrees ang full rotation. So pag tinivide mo by 8, ibig sabihin tig 45 degrees lang to. Indeed, di ba? Tig 45 degrees lang tong step niya. But the stepper motor is known for its very fine and very accurate stepping. Kaya nga tawag sa kanya stepper motor because you can control it at very fine angle. So what is this? What is inside the stepper motor to improve the resolution of the angle displacement? Well, sa totoo lang, if you break open the stepper motor, so the stepper motor that we have, the shaft is here. Actually, kung titignan niyo yung stepper motor natin, there are actually several gears that are attached to it. Okay? So these gears offer a gear reduction, kumbaga. So a full rotation of one gear or a single rotation of one gear would create a cascade towards the other gears, but will produce a smaller rotation in the final uh, gear. Okay, so if you look closely, there would be several gears before it is attached to the shaft, ano? And they will produce the gear reduction. They will produce the gear reduction. Right. So, depende yan sa motors, kung gaano kataas yung gear reduction na magagawa niya and gaano ka-fine. So, sometimes, depending on the gear, depending on the motor, this can go up to 2 degrees, and further design can go to less than a degree, okay? And if you need that fine angular displacement control. Okay, now let's go to our setup. I'll now share my camera and let's look at our uh, motors here. Okay, wait. Screen share ba? Hindi. Wait, open natin. Wala yung screen share. Ulitin ko lang. Zoom. Okay. And then, share content. Screen. Okay. Sorry na disconnect yun. Okay. I'll turn on the video. Okay. Focus lock. Focus lock. Okay. So, for controlling the motor, so bring out the following. Of course, your Arduino microcontroller. And this is the stepper motor that comes with the box. Okay. So, here's the shaft, and then you can attach anything to the shaft that you will control. So, if you break this open, you will see the fine-toothed gears that will allow a finer movement of this shaft. If you look at the specs, you can go ahead and search this online. This is the specs of this motor. It says here it's a 5-volt DC motor. Okay? And so bali itong ano niya, itong pin-assignments niya dito, it's also in the links that I showed you. But each of these would correspond, there are 5 because one of them is power, no? But each of these will correspond to, 4 of these will correspond, this colored one will correspond to the coil 1, 2, 3, 4. Another thing that you will need importantly is this. So this is the stepper motor driver. This is a bunch of resistors that will convert the digital input that will get in here. Di ba nga, nakita nyo dun sa table kanina, you need just to turn on and off some of the coils. But it needs to be there should be an increase in power, and that increase in power should be, or current will be implemented by this set of transistors here. And this is where you will attach this cable here to the motor. So essentially, all motors must be, like, maliit lang kasing current coming from these digital outputs eh. So you should let it pass through a set of transistors that will power it up. Okay, and this, notice here that this stepper motor controller, okay, has a power supply that you can enter 5 to 12 volts. Ngayon, may flexibility na 5 to 12 volts because depending on how heavy the thing you attach to the motor shaft is, kailangan mo ng higher current dyan. And therefore, it helps na you can enter more than 5 volts. You can put in more voltage and therefore more current to allow your motor to be able to rotate something heavier. Lastly, you might want to use this. This is optional, but this is for the case when you need to power up the motor. No? Now, this is a power supply module for Arduino. You can power this with a 9-volt battery so that it can supply 7 to 12 volts. So there's a bunch of transistors here. And then notice that you can draw from these pins. So my 5 volts, my 3.3 volts. Here, as you can see, my ground pins, ganyan, etc. So you can draw from these pins as a power supply. Also, there's a switch for safety. Okay, so you can either put a 12 volt here So remember, please, if you look at your box as well, you have an adapter for a 12-volt battery. And that's nice if you want it to be independent, like it's not connected to a power socket. So you can put that and put a 9-volt battery. Warning though, when you run a 9-volt battery to run a motor, it can draw the battery out quickly. Meaning, posibleng maubos niya agad yung battery. You can also use a USB power bank here as well in case. Okay? So, these are all you need. This is optional. Remember please, if the thing that you're carrying or rotating the motor is light, probably you won't need this. It's enough to draw the power from this power supply from the Arduino. However, note that pag bubigat yung dala-dala mo, forget it. Use a separate power supply for the motor. Okay? Okay. Alright. Okay? Okay. There. Alright, so how do you connect this? So I'll stop share from here. That's all you need. And then I'll stop share from here. Stop share. Now let's go to my other computer. I'll share from this computer. And share. So as I said, this presentation here. Oops, sorry, wait lang. Okay. So if you look at your Google Classrooms, now you look for motors, na andun yung mga requirements for the motors report. Here's the recommended outline. And here are the online resources. Very, very nice. So the program, for example, getting started with step one, let's visit this. And then there's a YouTube video, very detailed, on how to use this motor of ours with an Arduino, right? So let's go through this one. Okay. So that web page, that first web page, leads you to this Arduino page and how to use it. Okay. Now, here's what you need to. Let's just go through quickly the circuitry. By the way, I suspect there's something wrong here kasi parang baliktad yung pagkalagay niya ng ground and 5 volts. Okay? Parang napabaliktad niya ata yung double check this. Normally, warning to ha, please note, baka kasi pumutok yung ating devices. So, notice that normally if you have red, let's zoom that in. Normally, if you have red, that's plus 5 volts and negative is ground, ano. Double check, parang napagbaliktad niya guys yung ground and 5 volts. Tignan nyo, yung 5 volts niya nakakabit dito sa 5 volts niya is black and kinabit niya dun sa ground nitong motor driver. Okay? So essentially, mali ito. Napagbaliktad niya yung pins dito. Yung ground niya nakakabit doon sa and red pa yung gamit niya, nakakabit doon sa red and nakakabit dun sa plus volts. So, baliktad to. Pakibaliktad to. Warning yan ha. Pakibaliktad to. Okay? Baliktad yung drawing na. Essentially. Okay. Tapos, once you follow that, again, ito na yung sabi ko na okay. I-define niya yung ano to? 2, 3, 4, 5. Bakit ito? Yan. Okay. Okay. These are pins. Digital pins. And he will call these pins, kumbaga, linabel niya lang na A, B, C, D. But these are digital output pins 2, 3, 4, 5. Now, observe your Arduino. Makita mo doon, again ha, tignan mo. Dahan-dahan. Okay. Kinabit niya yung 2, 3, 4, 5 dito. these are the digital output pins starting from 2, no? So digital output, digital signal 2, 3, 4, 5, sinet niya to as output dun sa program. So it will output 1 or 0 depending dun sa design natin sa table. So pinangalanan niya to, just give it a name, ABCD. And ang pin mode assignment niya, ginawa niyang output. So signals will go out, it will not accept any input signal. So all of these will be out. Okay. So the next part, this one initializes. Okay, gumawa siya ng program for writing value into the digital pins, no? So, pag kinol mo yung write, tapos nag-set ka ng integers dito, maybe small ABCD, yan yung pupunta doon sa ABCD pins. Okay. Now, one step. Naalala nyo to, ito yung sequence nung table na ginawa natin earlier, right? What if you want it to point in this direction, then you first set one of them to 1, 0, 0. Tapos yung susunod, yung katabi niya na coil, iwan mo rin para 45 degrees siya ma-attract, no? Move. Okay. And so on and so forth. So you see the sequence, right? You notice the sequence. So essentially, naglagay lang siya ng 5 millisecond delay and pinamove niya yung stepper motor 145 degrees step at a time, no? Or at least yung internal motor, remember please, this will still undergo gear reduction. Okay? So ito, iikot na yan, pero pag tinignan mo yung yung motor, hindi siya iikot ng one full step. Yung motor sa loob, yes. Pero dahil may mga gears sa loob to reduce the step size of the external shaft, hindi ito magmumukhang nag-step siya ng 45 degrees. Okay? Okay. Now, essentially, you would, because of the gear reduction, you would need, it's explained in the YouTube video in the succeeding, you would need to do this full number of steps by 512 times. I believe it's 512 times, tama ba? Yeah, 512 steps per revolution. You need to do this full sequence 512 times so that the shaft will move one full 360 degrees. Okay? One full 360 degrees. So essentially, the gear that is in the stepper motor reduces the motion by 512. So, ibig sabihin, one full turn of this internal gear is just 1 over 512, okay? Or 360 divided by 512. Iyon yung magiging resolution, step resolution itong ating external shaft, okay? So, do this for 512 steps, itong one step na to, and then it will make a full 360 degrees. Okay. Alright. Now, let's go visit the other, medyo matagal tong YouTube video na to, but it will give you a very detailed explanation. Okay. So, if you follow this stepper motor YouTube video, maganda yung explanation niya. Marirepeat niya yung sinabi ko na kung paano nakokontrol yung motor by the coils. And it also, teka, whoa, stop. Bakit may excuse me po, nagkaroon ng okay, wait lang. Kasi natin to. Skip. Okay, so, yan. Okay, that's the sequence. Okay. 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 Now, yan. Okay. Okay. So, go through all of these, and I guarantee you it's a very nice explanation. But I want to point out this image here. Okay, ito na yan. So let's zoom on this and make it full screen. Ito yung sinasabi ko na pag binuklat mo yung motor natin, ito yung makikita mo. Here is the main motor. Ito yung 45 degrees yung nagmo-move. Yung every right natin, nagmo-move siya ng 45 degrees. Notice that there are several gears attached to it, and this produces a reduction of the number of steps para ito magmo-move lang after 512 full steps of this motor, 512 revolutions of this central motor here. Okay. So, and this explains ano yung steps niya kung paano to. Okay. Alright. There. So you can do finer adjustments with this, and you can design your own gear para, and there are several more expensive motors with finer resolutions, but essentially they act the same. This moves in 45 degree steps. There are several gears that will do the gear reduction, and this will rotate in a very fine step. Okay. So yan ha, basahin nyo yan. Very nice yan. Exit full screen. Okay. So, once you played around with the motors, this is the next thing that we will do. Stop share here. And I'll go to the other share content. Screen. Start broadcast. Ay, may tanong ba so far? Again, all of this is in the Google Classroom. Okay. And then, okay. So, what do we mean by the digital sunflower? Or rather, the electronic sunflower. So, essentially, di ba may LDR tayo? And you can detect already by reading the analog voltage in a circuit kung meron bang sunlight or wala, and kung mataas ba yung level ng sunlight, right? So imagine attaching this LDR somehow to the shaft of your motor. So for example, sorry, na stop yung sharing. Sorry, yung napindot ako. Share. Stop broadcast. Okay, ulit. So I was saying, so for example, ang ginawa natin ay ginawa natin ay, ito yung motor, pinahiga natin ng ganyan. Ito yung shaft niya. And somehow, nakabit mo yung LDR sa kanya. So, hindi ko alam kung anong black box mo dyan, but the LDR is connected, right? Like so. Okay. And therefore, this is free to rotate depending on your program. So, for example, maglagay ka ng flashlight dito as a proxy for the sun. Okay? Dapat, ang gagawin ni electronic sunflower is, sasamplein niya dito, rotate mo muna dito, titignan mo yung voltage value. Tapos, imomove mo siya another step. Bahala kayo sa delta angle dito, no? Kasi isasample niya yung brightness dito. Iko-compare niya dito sa brightness na measure niya in this position. And then, you will read and read and read in all different positions, and then you will compare kung saan yung brightest. Okay? And then you will finally turn the electronic sunflower to where it is brightest. So kung kunyari nandito nga yung flashlight and all the rest is dark, no? it should turn, in the end, it should turn like this. Okay? You understand the idea? So, one suggestion would be, you can sample first. So, kumbaga, you can sweep first. Ganun naman eh, may mga ganun naman na isi-sweep mo muna para isample mo kung anong brightness dito sa different angles na to. Tapos, titignan mo yung position kung saan yung brightest. Tapos, papapuntahin mo siya doon sa position na yon, kung saan ang brightest. So, you sample first, and then, you go back to that position where you saw the maximum brightness. Okay? Can you do that? So yun ang gusto ko sanang paglaruan nyo. First, play with your motors. A lot of things can be done with motors. It's very fun. And I hope you enjoy making your own electronic sunflower. Okay? Any questions? I'll stop here. Okay. Alright. If you have any questions at all, even during the Christmas break, go ahead and please message me. I'm open to that. Just message me and I'll try to answer your questions. Thank you very much for attending this discussion. Do you have any questions? Okay. So if none, I'll post this recording with some other materials. Please visit your Google Classroom. Some of the materials or the videos are already posted there. Okay? And if you know somebody, I have a spare Arduino kit here. So kung meron pang may isa sa inyo na wala pang kit, sabihin nyo lang, sabihan siya na sabihan ako and I can send the Arduino kit. Okay? So thank you very much for attending. Please visit your Google Classroom for more details. Okay, I'll see you again next meeting. We will meet once again for last week of classes in January. Okay, no questions? Thank you for attending. I'm very, very sorry for mistaking this to be our last day of classes. So, pasensya na. But thank you just the same for coming over kahit break na natin. Sige. Thank you guys. Bye-bye. And meeting for all.